Assalamu alaikum dear students. Today I will show you the detailed procedure to draw bending moment and shear force diagrams for a cantilever beam. Now this is the question here. The span of the beam is 6 meters and there are 3-point loads. One is 4 kilonewton, another is 3 kilonewton, another is 2 kilonewton. This load is at a distance of 2 meters from the fixed end. Next load is at a distance of 4 meters from the fixed end, and third load is at a distance of 6 meters from the fixed end. Now there are various steps how we will draw the bending moment shear force diagram of this cantilever beam. First of all, I will label this beam that it is A, this is B, this is C, and this is D. Since we know that in case of a cantilever beam there is only one direction, and that is at the fixed end. That direction is equal to sum of loads. That means only one direction, RA, that is equivalent to sum of loads, and that is equivalent to 2 kilonewton plus 3 kilonewton plus 4 kilonewton, and it comes 9 kilonewton. That means this is 9 kilonewton. These are the forces. Their direction are downward, and direction here it is the direction of direction will be upwards. After that, what I will do, I will draw the projection downwards along the loads and along the ends. This is one projection, second projection, this is one more projection, and this is one more projection. After that, I will draw a line known as a reference line or neutral axis. Okay. Now RA is 9 kilonewton and the direction of direction is upward here. I will move upwards 9 kilonewton. From this point to this point there is no load, go straight. Here the load is 2 kilonewton, come down 2 kilonewton. The remaining here is 7 kilonewton. Again move forward. Direction of the load is 3 kilonewtons down, because the direction of the load is downwards. Remaining remains here 4 kilonewton. Again move forward, and load is here 4 kilonewton. Here it is 4 kilonewton. After that, this is the positive. It is because of that, due to sign conventions, we are taking it as positive, as we have already discussed it in the previous lecture. Now what is shear force at A? The shear force at A is 9 kilonewton. Kindly note it properly here. Whenever you will see the shear force, you have to calculate it from point of reference to outer edge. This is 9 kilonewton. The shear force at B is again 9 kilonewton, because we are considering the outer edge. And shear force at C is 7 kilonewton. Shear force at D is 4 kilonewton. After that, I will go hatching, internal hatching or inner hatching. It is because of that, did you know why we are doing inner hatching? It is because of that the section is solid section. The section is solid section. This is the required shear force diagram. Now, after that, I will write the details of shear force diagram. Details of shear force diagram. Shear force at A, that is plus 9 kilonewton. Shear force from A to B, it is constant. A to B, it is plus 9 kilonewton. Shear force from B to C, that is plus 7 kilonewton. Shear force from C to D, that is plus 4 kilonewton. This is the unique method for drawing the shear force diagram. First I draw the diagram and then I am writing the details of shear force diagram. Remember it. Now regarding the bending moment diagram, again draw a line known as neutral axis or reference line. Now in case of cantilever beam, bending moment is always 0 at the free end and it is maximum at the fixed end. And whenever you want to calculate the bending moment in case of a cantilever beam, calculate it from free end. You can calculate it from the fixed end also. I am not telling you that you will not calculate from the, but it is very convenient for the students to calculate it from the free end. Now regarding the bending moment diagram, first I will write the details of bending moment diagram. Bending moment diagram. B means bending, M means movement, D means diagram. Okay? Bending moment at D, that is automatically 0. अगर हम देखेंगे भी यहाँ, देखिए 4 किलो न्यूटन, डिस्टेंस कितना है डी पर? 0. 4 किलो न्यूटन multiplied by 0, it comes 0. Bending moment at C. Bending moment at C, that is minus 4 kilonewton into 2 meter minus 3 kilonewton into 0, it comes minus 8 kilonewton meter. This is also minus here. It is because of that in case of bending moment we are taking the signs. Downward we are taking positive, upward we are taking negative. Okay? It is not necessary that I will take that. Take it as positive, take it as negative. It depends upon the student कौन सा sign वो कौन सी लेंगे. Clockwise movement and anti-clockwise movement. If you will take clockwise positive, take anti-clockwise negative, or vice versa. Am I right? That is why I am writing minus minus. Okay. This is bending moment at C. After that, bending moment at D. Bending moment at D is bending moment at D. Bending moment at B. Okay, bending moment at B, that is 4 kilonewton multiplied by 4 meter minus 3 kilonewton multiplied by 2 meter minus 2 kilonewton multiplied by 0. देखिए यहाँ मैं आपको दिखाऊंगा 4 किलोन्यूटन कितना दूर है ये? 4 मीटर. दूसरा लोड क्या है? 3 किलोन्यूटन. कितना दूर है ये? 2 मीटर. तीसरा लोड क्या है? 2 किलोन्यूटन. कितना दूर है ये? 0. First load is 4 kilonewton at a distance of 4. Second load is 3 kilonewton at a distance of 2. Third load is 2 kilonewton at a distance of 0. And जब हम इसको कैलकुलेट करेंगे, it comes minus 16 kilonewton meter and minus 6 kilonewton meter. It is here. That is 22 kilonewton meter. This is bending moment at B, right? After that I will go bending moment at A. Bending moment at A is minus 4 kilonewton multiplied by 6 meter minus 3 kilonewton multiplied by 4 meter minus 2 kilonewton multiplied by 2 meter. It is minus 24 kilonewton meter minus 12 kilonewton meter and minus 4 kilonewton meter. It comes minus 40 kilonewton meter bending moment. This is bending moment here. See here. First 4 kilonewton, it is at a distance of 6 meters. Second load is 3 kilonewton, it is at a distance of 4 meters. Third load is 2 kilonewton, it is at a distance of 2 meters. That means 4 into 6, 3 into 4, 2 into 2. पहला लोड है 4 किलोन्यूटन, कितना दूर है ये 6 मीटर. दूसरा लोड है 3 किलोन्यूटन, कितना दूर है ये 4 मीटर. तीसरा लोड है 2 किलोन्यूटन, कितना दूर है 2 मीटर. And movement is product of force into perpendicular distance, and that I am doing it here. It comes 40 kilonewton meter, right? And put here, this is bending moment at D is 0, bending moment at C is 8 kilonewton meter, bending moment at B is 24 kilonewton meter, and bending moment at A is 40 kilonewton meter. Now, since they are point loads, they are concentrated loads, we will join them with the help of scale. This point, this and this, and this and this. This is the bending moment diagram. Inner hatching again. Bending moment diagram. Now remember, in case of cantilever beam, there is only one direction, that is at the fixed length. This direction is equal to sum of loads. Calculate bending moment always from free end in case of a cantilever beam. Third is bending moment is 0 at the free end and it is maximum at the fixed end. This is the required bending moment and shear force diagram. Thank you.